Now, what is static electricity? Well, it's actually a buildup of charge. So what our static electricity is when things rub together, that means that there is a buildup of that charge or those positive and negative electrons. So here I have what we call a Van de Graaff machine. So when I spin this wheel, it has a little belt that it rubs together just like this, and it's actually building up a charge right here on the silver ball. Now I'm going to turn off the light so that you can see our static electricity. So as I am winding this up, we are building up charge. And when I use this is called a ground. It kind of looks like a magic wand, but this ground is going to help us to discharge some of that built up electrons in there. And so when I get it close enough, you should be able to see a really big spark. So let's take another look at that once again. So we're building up some static charge. So static charge is often built when things kind of rub against each other or when they move close by to each other, which is how we get lightning, is because ions in the air and in the water in the clouds are rubbing against each other. And then when they get close to a ground, they create static electricity and they discharge that static. Turning my lights back on. There they are. All right, so that was pretty cool. But our next question is, what exactly was going on when we were building up that static electricity? So as I said, there was an imbalance of charge. More electrons, which are negatively charged, were building up on the surface of my Van de Graaff here, and then were discharged when they were close to the ground, which means that they had a place to go so that they could become neutral once again. So here in this little diagram, we can see that the top plate here has a lot of negative charge on it and not very much positive charge, whereas the bottom plate here kind of looks equally distributed between that positive and the negative charge. So if we were to bring these two plates together, we might see a spark jump between those two plates in order to neutralize those positive and negative charges so that there's no longer an imbalance. Now we can also create this kind of imbalance using some very simple tools. So for example, I have a PVC pipe and a dry cloth, just like we see here in this picture. Now what we're going to do is rub these together. And when we do, the dry cloth is going to give away some of its electrons to this PVC pipe. And as it does that, the PVC pipe is going to become negatively charged rather than the neutral charge that it had before. Now, once this negative charge is built up on our PVC pipe, we can actually use it to manipulate some objects. So here I have an empty soda can, and we're going to see if we can move this can just using the power of static electricity. So we're building up that negative charge here on this PVC pipe. And when we get it close, this might not be able to build up enough charge. Should have used a balloon. Let's try it with a balloon. So a balloon has more surface area than this PVC pipe, which means it should be able to do this much easier. All right, so when we tie off this balloon, right now it has a neutral charge. We're going to rub it on this dry cloth once again to build up a negative charge, and then we'll see if we can really move this can just using static electricity. Sometimes as scientists, we need to reevaluate our experiments and try again with something new. All right, this balloon is feeling very staticky here. So let's see if we can move this can. And you can see without even touching the can, we're able to pull it towards us at quite the speed, I might add. Now that's because the negative charge that is built up on the balloon is attracting the negative charges here on the can. Even though the can has a neutral charge, that means that there's a balance of positive and negative charges, which means that those negative charges on this can are being attracted to this balloon and pulled towards it. This is a really easy experiment to try at home to test your hand at static electricity. Now, I want to go back to that first question that I asked. I said that in my laundry, my really, really heavy sweaters and my socks, my wool socks, were all being statically clung together. And I was wondering how to get rid of that static cling. Now, here in the wintertime, because we have the heat going inside of buildings, it causes dryness in the air. That's because cold air holds less moisture than warm air. So as we take that cold air from outside, we put it through our heating systems and then pump it through our buildings to keep us nice and warm. It actually is pumping drier air throughout our buildings than we would experience in the summertime, with the opposite. If we took hot air from outside, cooled it down through an air conditioning system, and then put it into our buildings. So overall, there's less moisture in the air, which accounts for, number one, the dryness in my dog's fur, and number two, the dryness in my clothes that come out of the dryer. So I actually went to the store to see if there were any solutions for this problem. And I found this stuff called the static solution. And you can see here, it's listed these ingredients: deionized water, essential oils, and fragrance. Now, essential oils and fragrance, I know, are not to help with the static cling, but rather just for a nice scent. But the deionized water was interesting. I know that electric charge can travel really easily through water, especially tap water, which is full of minerals. But when we deionize water, basically we're purifying it. We're taking out a lot of those mineral ions so that that water is without charge. Now, this stuff does work pretty well to get rid of the static cling in my clothes, just with a couple sprays. But I was wondering, could regular tap water or distilled water work just as well? Just without those fancy smells. So that's an experiment that I'm going to try, and I challenge you to try as well next time you feel your clothes clinging to you with static. Some other solutions, of course, are to add moisture to your environment. So getting something like a humidifier or turning up the humidifier in your home would definitely help with that air dryness and that static cling. Another option is to make sure that your skin is well moisturized, because if you have really dry skin, that can mean that those clothes are going to cling to you even more, looking for that moisture that will help to wick away that static cling. Another option is just to air dry your clothes. Some people like to use dryer sheets. I think a more environmentally friendly version would be to just air dry your clothes. You'll save energy and those one single-use dryer sheets. There we go. So those are some great options to help you eliminate static cling if it's a problem for you, like it has become a problem for me. Hopefully, this little lesson in static electricity has helped you understand just why things are happening the way they are in the winter time with all this dry heat. And hopefully next time you see some static electricity, you can explain it to one of your friends as well. So that brings us to the end of this episode of Echo Live. Thank you all so much for tuning in. Make sure you join us next Wednesday, March 2nd, same time, same place. Once again, my name is Angela, coming to you from the